Here, so what is a power series? Here's a function, and here are some other functions that are, in fact, the y sub 2 is a linear equation. It's linear. How do I know that? Raised to the first power. What's the graph of y sub 3? It's a parabola. Y sub 4 is some cubic polynomial function. Y sub 5 is a polynomial function. What would y sub 6 be? Another polynomial function. And in the calculator, I'm going to put f of x into y sub 1. So that's 1 divided by, I'll open parentheses, 1 minus x, close parentheses. Y sub 2 is going to be 1 plus x. Y sub 3 is 1 plus x squared. Y sub 4 is 1 plus x squared plus x raised to the third. Y sub 5 is 1 plus x squared plus x raised to the third plus x raised to the fourth. Did I mess up? Oh, I did mess up. Let's back up there. Thank you. Well, plus x raised to the fourth. Okay. And if we want, we'll put in the other. Let's go with those for now. I'm going to go to Zoom Standard on the calculator, and then we'll play around with it. And Zoom Standard, you're not going to get a very good picture, but Zoom Standard sets the screen from -10 to +10, and from the y-axis, -10 to +10. That's the screen that was programmed in it when you took it out. There's my first graph. Here's my linear. There's the parabola. Here's the cubic. And now y to the fourth is in there. And what happens is this. The polynomial functions within a certain area of x are a very good approximation for f of x, which is 1 over 1 minus x. I'm going to zoom in. I'm going to change the window a little bit to get a better picture. How about if we go x min -3, x max is 3, y min, I'll do the same, and hit graph. And here's f of x. There's the straight line. Here's the parabola. Now the cubic. And finally the 1 to the fourth power. And now you can see on the edges here, these polynomial functions are not good approximations for f. But it looks like maybe between -1 and 1, they might be a very good approximation. Let's try the window -1.5 to 1.5, and I'm going to leave the y's -3 to 3 and hit graph. Here's my f of x. There's my straight line. There's the parabola, cubic function, and then the one that's to the fourth power. And as I keep adding terms to these guys, this is going to be a better and better approximation to the graph of 1 over 1 minus x. So I could say I am representing this function with, these are power series. Power series Well, these are polynomial functions. A power series is an infinite type of polynomial. So a power series, in this case, might be 1 plus x to the first plus x squared plus x cubed plus x to the fourth plus, it goes on forever. It is a series, but it's a polynomial type, it's in polynomial form. The exponents are positive integers. This is the topic for 11.8, 11.9, and 11.10. 11.8 is talking about the convergence of what values of x would something converge. For that, you need the ratio test. 11.9 is using actually this problem right here and representing all kinds of functions as power series. It uses a lot of algebraic tricks, that's all. 11.10 is how can you find it of any type of function. Okay.